Once a mission ends or an emergency return is ordered, you have to follow a strict set of procedures to ensure a safe descent. Your spacecraft has to be positioned at a very specific altitude and angle relative to Earth's surface. If you're not lined up properly, you literally cannot land where you need to. Think of it like trying to jump off a moving train and land on a specific platform, except the train is moving at 17,500 miles per hour and the platform is spinning. If you miss, you die. Solar mood swings. Okay, so you're aligned, that's great, but now you have to check the space weather forecast. Yes, space has weather as well, and it's way worse than anything on Earth. The sun constantly throws out bursts of energy called solar flares and coronal mass ejections. These events release high-energy particles and electromagnetic radiation that travel through space at extreme speeds. When they hit Earth's magnetic field, they usually create geomagnetic storms. These storms can fry electronics, scramble GPS signals, and disrupt communication systems. If the navigation computer gets hit with a surge of charged particles during re-entry, it could cause miscalculation of your landing trajectory. In re-entry, a few degrees off means you burn up or simply bounce off the atmosphere into space. And remember, many of the rules exist because of past disasters. They're written in response to things that already went horribly wrong. So before you come home, Mission Control checks solar activity. If the sun is throwing a tantrum, you wait. The narrow door. Even if you're aligned well and the space weather seems calm, you still need a re-entry window. This is a very specific time slot when all the conditions line up for a safe descent. These windows are short, really short, sometimes just a minute. If you miss the window, you can't just slam on the brakes and try again. You're in orbit and moving at insane speeds. You have to wait for the next opportunity, which could be 90 minutes later or sometimes much longer. NASA and other space agencies calculate these windows down to the second. Miss it by a few minutes, and you're sent on another lap around the planet. And every lap means burning more fuel, using more life support, and hoping nothing else goes wrong. The invisible obstacle. Alright, so you've got your window. Now comes the part nobody talks about, how thick the air currently is. Earth's atmosphere isn't static. Its density changes based on solar activity, time of day, and even the season. When the sun is more active, it heats up the upper atmosphere, causing it to expand. This increases atmospheric density at higher altitudes, which means more drag on your spacecraft. More drag means more heat, and during re-entry, your heat shield is already dealing with extreme temperatures. If the atmosphere is denser than expected, the friction increases, and you risk overheating critical systems or even burning through the heat shield. On the flip side, if the atmosphere is less dense than predicted, you might not slow down enough. You could skip off the atmosphere like a stone skipping on water and end up back in space with no fuel left to try again. So Mission Control monitors atmospheric density in real time. If it's outside safe limits, the re-entry is delayed. You can't just wing it and hope for the best. That only works in movies. The final hurdle. Let's say everything I mentioned checks out. Now you have to deal with Earth's weather. Your landing zone is predetermined. It's usually in the middle of the ocean for capsules or a flat stretch of land for spaceplanes. But if there's a storm, high winds, rough seas, or low visibility, unfortunately, you're not landing. Wind speed is critical. Too much wind, and your parachute can't stabilize you. You could drift off course or land hard enough to tear the capsule apart. For ocean landings, size matters. If the seas are too rough, the capsule could flip or take on water after splashdown. Cloud cover affects visibility for recovery teams. If they can't see you, they can't get to you quickly. Landing zones are limited. There are only a few spots on Earth that are safe and logistically feasible for spacecraft recovery. If the weather is bad at all of them, you're stuck in orbit until conditions improve. Space traffic control. You'd think it's empty up above, with plenty of room for everyone. Wrong. There's traffic up there too. Satellites, space stations, other spacecraft, and thousands of pieces of space debris all orbiting Earth at different altitudes and speeds. Before you can re-enter, Mission Control has to make sure your trajectory doesn't intersect with anything else. Space traffic is managed just like air traffic on Earth. Timing has to be coordinated so nobody crashes into each other or creates a debris field that puts everyone at risk. So even if you're ready to come home, you might have to hold because someone else is in your way. No room for error. Now let's talk about your ride. The capsule itself has to be in perfect working order. We're talking about parachutes, thrusters, stabilization systems, and most importantly, the heat shield. Heat shield is what keeps you from turning into a fireball during re-entry. It's designed to ablate, meaning it burns away in a controlled manner to dissipate heat. But if there's any damage, even a small crack or chip, the intense heat can penetrate the capsule. And if that happens, you're done. Parachutes have to deploy at the right time and in the right sequence. Main chute, drogue chute, and backup chute. If one fails, you're falling too fast. Thrusters are used for last-minute adjustments to your landing position. If they malfunction, you could land miles off target. Every single system is checked and rechecked before re-entry. If mission control detects even the slightest uncertainty, the return is postponed. Because in space, good enough doesn't exist. It's either perfect or catastrophic. If you liked this video, don't forget to subscribe. I'll see you in the next video.